Okay, this lesson is about solving systems of equation by substitution and elimination. So the last video we talked about how a line has an infinite number of solutions. It has xy pairs, those are solutions. So for example, if I had this equation, it has two variables, it has an infinite number of solutions. I'll give you two of them. If I plugged in 0 for x, this is supposed to be a 0. That would give me 0 plus y equals 3. So that's one solution, 0, 3. If I plug in 0 in for x and 3 for y, then I get 0 plus 3 equals 3, which is true. That's a solution. So a solution is a value for the variables. It's values for the variables that make the statement true. So another solution would be 2 times 1 plus y equals 3. That would make y equal to 1. So another solution would be when x is 1, y is 1. So this is another solution. If I plug in 1 for both of the variables, I get a true statement. 2 plus 1 equals 3. That's true. So when you have a line, there's an infinite number of solutions. With a system of equations, if you have another line, you have another infinite number of solutions, but the only thing that is a solution to both of these lines is the place that they intersect, one point. And that's how you find it by graphing, but today we're going to turn to substitution and elimination as methods to find the solutions without graphing. So substitution is the first method we'll talk about. And the strategy behind substitution is you're going to solve one of the equations, either one, for where you have one variable by itself, and then you're going to plug that variable back in to the other equation. So I'm going to start with this equation, and the reason why is there are no coefficients for the x or the y, so it's going to be easier to solve for one of the variables. I could use the top equation, but because they have the coefficients 2 and -3, it would just make it a little more difficult. To solve this equation, all I have to do is subtract y from both sides, and I've solved it for one of the variables. X is equal to -12 minus y. Now the nice thing about that is this is what x is equal to, so I can come back up into this other equation and plug in for x. So 2 times x, which is -12 minus y, minus 3y, is equal to 6. Excuse me. Now I have one equation with one variable. It shows up in two places, but it's the same variable. So now I'm going to solve this. Distribute the 2. 2 times -12 is -24. 2 times -y is -2y. And then I just copy down the rest of it. Now I'm going to combine like terms. -24. -2y minus 3y is equal to -5y. Add 24 to both sides. And I get -5y is equal to 30. Divide by -5. And the solution is y equals -6. That's the y value of the solution. I'm going to plug that back in for y over here, and that's going to give me the x value of the solution. So x is equal to -12 minus y, and y is -6. So x is -12 plus 6, which is also -6. So my solution to this is x was -6, y was -6. What this means is if I plug -6 in for x and y, both of these statements should be true. So let's test. 2 times -6 minus 3 times -6 is equal to 6. That gives me -12 plus 18 equals 6. That's true, it works in the first case. Let's plug it into the next one. -6 plus -6 equals -12. It works for both equations. It's a solution to this system of equations. So that's the substitution. I want you to go ahead and try and solve this one. You can pause the video and try and solve it. If it was me, I would solve this equation first. I would get y by itself because that's the easiest thing to do. Okay, so the solution that you should get for this one is 2 comma x Oh, I'm sorry, I'm looking at the wrong one. 4x minus 2y. Oh no. Is 2.5 comma negative 2. Or sorry, yeah. So that's the solution that you should have got. I'll plug it into the first equation to show you that it works. 4 times 2.5 plus 3 times negative 2 should equal 4. 4 times 2.5 is 10. Plus negative 6 equals 4. And that's true. Let's plug it into the second one. 2 times 2.5 minus negative 2. That should give me 7. This gives me 5 plus 2 equals 7, which is also true. Okay, now we're going to switch to the method elimination. So it's the same concept. We're trying to find the solution, the values for the xy pair that works for both of these equations. But with elimination, what you do is you combine the two equations into one equation by adding the x values and adding the y values and adding the solutions together. So I'm going to demonstrate that with this, which is an easier problem, and then show you how to do it when things don't line up so nicely. So if I add both, so I'm just going to add these two equations. If I add 4x plus x, that gives me 5x. If I add negative 2y plus 2y, that cancels out and I don't have any y's. If I add 7 and 3, I get 10. If I divide both sides by 5, oh no, my computer's freezing up a bit. If I divide both sides by 5 over here, the 5's cancel out, and then over here 10 over 5 is 2. So 2 is the x value, and then I go plug 2 back into either of the equations. I'm going to use the bottom equation because it's easier. So 2 plus 2y equals 3. So 2y is equal to 1 if you subtract 2 on both sides. And then that gives us y is equal to 1/2. So 2 comma 1/2 is the solution to this equation. Alright, let's do an example that's not so straightforward. So here, if I were to add these two together, it wouldn't really help me right now. I would get 8x plus 9y is equal to 11. And that's fine. I have another equation that works and that has a same solution in this system of equations, but it doesn't help me at all because I still have two variables. I have x and y. So what you want to do first is you want to get, like we had on this previous problem, the thing that was nice about this is one of the coefficients for y was negative 2 and the other coefficient was positive 2, so that when we added them together we got rid of y. We eliminated one variable. So let's try and do that on this one. We want to eliminate one variable, so we want the coefficients to be the opposite of each other. Since we did y last time, I'm going to do x this time. We want to eliminate x, so we want this term and this term to have opposite coefficients. So what I'm going to do is I'm going to multiply this entire equation by negative 5. I'm going to multiply this entire equation by 3, and we'll see that this is going to give us coefficients for the x that are opposite of each other. So negative 5 times 3x is negative 15x. Negative 5 times 7y is negative 35y. And negative 5 times 15 is negative 75. Let's do this one. 3 times 5x is 15x. 3 times 2y is 6y. And 3 times negative 4 is negative 12. Okay, you can see now that negative 15x plus 15x, when we add these two equations together, this is going to go away. It's going to disappear. So that's why I picked the numbers negative 5 and 3. Because I knew that negative 5 was going to give me negative 15 and 3 was going to give me 15x. So what you're looking for, this number 15, is the least common multiple of 3 and 5. It's the first thing that 3 and 5 both divide into evenly. So that's what you're going to want to look for the coefficients. You're looking for the least common multiple. Okay, let's add these two together now. Negative 15x plus 15x gives me 0x, so that goes away. Negative 35y, so these cancel out. Negative 35y plus 6y gives me negative 29y. Negative 75 plus negative 12 gives me a negative 89. If I divide both of these by negative 29, I will get 3, maybe. Let's see if that's true. 3 times 29 is 60 plus 27. Oh, this should be 87. Okay, sorry, I added wrong. So yeah, this does give you 3. So now let's go find out what x is. You can plug it into either equation. I'll just plug it into the first equation. 3x plus 7y, well y is 3, equals 15. So 3x plus 21 is equal to 15. 3x is equal to negative 6 if you subtract 21 from both sides. So x is negative 2. So here's our solution, negative 2 comma 3. If you want to check your solution, you need to plug it into the other equation. So I plugged this into the first equation also. I plugged it into the first equation to figure out what x is, so I need to plug it into this second equation to figure out, to check it, to see if it's right. So 5 times negative 2 plus 2 times 3 should give me negative 4. 5 times negative 2 is negative 10. 2 times 3 is 6. That does add up to give you negative 4, so it works for both equations. This is a solution to our system of equations. Alright, let's move on to the next one. So we're going to solve this one by elimination. This one we already have opposite coefficients, so let's just add these two things together. If you add 2x and negative 2x, you get 0. If you add negative y and positive y, you get 0. If you add 3 and negative 3, you get 0. So I have 0 equals 0. What just happened? Well, if we go back to solving by graphing, what we have here is you have one line, and then you have another line exactly on top of it. Okay? And what that is these are really the same equation. They're just written different ways. If I multiply this top equation by negative 1, I get negative 2x plus y equals negative 3. That's what the bottom is. These are dependent. This is a dependent system. What that means is if you have 0 equals 0 when you solve by substitution, well, this is true. It means it works and it doesn't depend on x and y. No matter what I plug in for x and y, it's going to be the same for either one because this is the same line. So there's not one unique solution. There's an infinite number of solutions. That doesn't mean anything is a solution. So for example, 0, 0 is not a solution. 2 times 0 minus 0 equals 3. That's not true. That's 0 minus 0 equals 3. That's not true. So that not everything is a solution, but there are an infinite number of solutions. So if I plugged in 1 for x, I could find a y that would work. Positive 1. So if y was negative 1. So here's a solution. And I could keep doing this. I could keep plugging in something for x and solving for y, and I would have another solution and another solution. Let's go ahead and do it with 0. 2 times 0, since we saw 0, 0 is not a solution, that gives me 0 minus y equals 3, so y equals negative 3. So 0, negative 3 is a solution. And it works for both of them. Any solution that works for this one will work for that one. And that's what happens whenever you use elimination and your variables go away. So let's do elimination again. In this case, 2x plus negative 2x, again, they're the opposite, so we can add them together and you get 0. Here you get 0 again, and then here you get 12. So again, we don't have any variables in our solution, but this time this statement is not true. If you get a statement that's not true after elimination, the situation that you have is parallel lines. So if I were to graph both of these, I would have parallel lines, and if I had parallel lines, that means there are no solutions that they share in common. There's nothing that's a solution to this equation that is also a solution to this equation. So there's no solution here. No solution. And the other one, there were an infinite number of solutions, but there were no unique solutions. Here, there's no solutions that work at all. Alright, that's it for today.